Hello Science 10 students. My back's still not feeling well, so I thought I'd come in, give you a quick lecture on how to handle this naming stuff. It looks like Mrs. Pfister gave you the material yesterday, and you guys have already started it. I don't know how far you got. You do need to do every single one of those questions. Be forewarned that probably tomorrow on Friday, you're going to be getting a big assignment for marks. It's 200 questions, I'm not lying, and you have to have every practice question done in order to get that assignment. So make sure that if you started it, that you think, oh, I got this. Great, you got it. Keep on going and finishing it. So anyways, the basic principle though when we're making compounds, I just want to make sure that we're on the right track here, that we sort of know what we're doing, is that you have a positive ion, you have a negative ion. When they come together, they're going to make a compound. They're going to make a situation where the overall charge is neutral. So in other words, if I go and say have lithium, which is Li positive, combining with chlorine, which is Cl negative, you should know this if you started this sheet, I hope, that one positive cancels off one negative, they come together, that's all you need. You don't need to do anything else. It's LiCl, lithium chloride. Now, if those charges are a little bit different, say with calcium and chloride, well, in order for the positives and the negatives to be equal, I need two of these negatives to balance off this one positive. So it's CaCl2 because I need two of these to counter off that positive charge. 2 negative, 2 times negative 1 is 2 negative, equals 2 positive, or doesn't equal 2 positive, it cancels off 2 positive, net charge is 0. Now you don't have to actually do that complicated math. I know it's not that complicated, but I'm sure you can handle it. But there is an easier way. Just take this number here, put it over here. Take this number here, and we don't put ones, but that would go over here, okay? And we don't put the 1 here, but you need 1 calcium and 2 chlorines to cancel everything off. So if you do what I call the charge switch, you'll be fine every time, and you don't really have to think about it, at least at the beginning, when they're easier. So for example, if you have, say, aluminum, and sulfur, sulfide in this case because it's an ion, we put them together, and I always say put them together without any numbers there or anything. Then the 3 goes over here, the 2 goes over here, and that is your final answer, Al2S3. Now, this is a significant part of the course, is naming these formulas. Make sure you do them right. This is the correct format. It's not this. I'm marking that wrong. It's not this. It's not this. Or any other kind of situation. If you're doing this, you might do this. But then you're keeping the charges up here. I'm marking this wrong too because you still got the charges there. It has to be that, okay? So when we did the opening booklet and I said, make sure that you got units for everything, and you all went, I'm gonna say this time, make sure that you have your numbers subscripted down low, everything's capitalized properly. Any other method is incorrect. Not kind of right, not sort of right, it's wrong. So make sure you follow the right format. Now the biggest thing, or the biggest trick out of that first day, or that first sheet, I don't know if you've come across this yet, but you will, is say something like that guy. We put him down, we do the charge switch, 2 and 2, and some of us are gonna think, oh, we're done. Well, the situation is though, 1, 2 positive cancels off 1, 2 negative. I don't need 2 Mg's and 2 O's to cancel each other off. I just need 1 of each. And so then really all I need to do, can't quite get that guy, is just say I have 1 of each. So if I end up with a 2 and a 2, it's like they cancel off. And I just have MgO as my answer. Okay? So that's about as complicated as it gets when you're making formulas on that first batch of questions. Okay? And if you haven't noticed, you're only using this part of the charge sheet up here in the top. Now there's a whole other part. There's some part there in the bottom. And then there's also on the back side, you haven't touched those yet, and I'm going to explain those to you. Now, I'm hoping that doing the formulas, or sorry, doing the names has been easy for you, but let's just quickly do that quick. Let's go CaO. You look up Ca, it's calcium. You look up O, it's oxide, and so that's calcium oxide. If you use the periodic table to find your stuff, it's going to list this as calcium and this is oxygen. If you label it calcium oxygen, it's wrong. When it's a compound, the second word ends in IDE most of the time, not all the time. You're going to see some other exceptions to that. But that's how that works. Okay? So, what we are going to do next is that we should more or less be okay with this. Okay? From the notes that you had from yesterday and from the explanation that I gave you quickly, I'm hoping that you can do these first 60. Every single one of them. Not 29, not 25, all of them. Not every second one, all of them. Okay, let's talk about common name system. And then the other one, which is kind of related, is the stock system. So I'm more or less going to talk about these two systems at the same time. Okay, so if you look here on this part of your chart sheet, this is page 1. Why it's doing this, I don't know. Stupid thing. All right. You'll see down here in the bottom half of the first page that, for example, chromium has got two versions of it. There's Cr2+, Cr3+. Cobalt is CO2+, CO3+. Copper is Cu+, Cu2+. They're not always the same charge, but they'll have two versions of it. Might be 1 and 3, 2 and 4, 2 and 3, whatever. You have to be able to tell the person looking at your formula or looking at your name which one of those are using. And there's two different ways you can do that. There's the stock system, which involves Roman numerals like this, and then there's the common name system, which has suffixes at the end of us and ik, chromus, chromic, cobaltus, cobaltic. And that's kind of how they distinguish between the two. So, So for example, if we have, say, iron 3 chloride, and you need to make the formula for that, that's actually not any different than what we've done so far. If you look up iron 3, you'll find that that's Fe3+, chloride is Cl negative, you put them together, switch the numbers, and it becomes FeCl3, and that's your answer. Okay? Now, you may get a name called ferric chloride. Well, if you looked up ferric, it's Fe3+, chloride still Cl negative. You do the charge switch, it still ends up being FeCl3. Okay? So the stock system and the common name system are exactly the same thing, except you're just using different endings. So I think you're going to be fine doing it, making the formulas. However, if we're doing the name, and let's go with, say, Cu Br2. Okay? This guy here, his charge is going to be Br. So here's what the possible answers are. It could be copper 1 or copper 2 chloride if we're using the stock system, or it might be cuprous or cupric chloride if we're using the common name system. How do you know which one you're using? Well, this is Br, and he's Br negative. So he's got a charge of -1, and then you got 2 of them. And so the reason why you have 2 of these is because it's canceling off this positive charge. So if this side is 2 negative, this side must be 2 positive. The charge over here must be 2 positive, and so therefore he'd have to be copper 2 chloride or cupric chloride. Okay? So let's do one more of those. Let's go copper. Oh, I did copper. Let's go iron again. Let's go. Okay. So there's iron. He could be iron 2 oxide or iron 3 oxide. Okay? Or he could be ferrous or ferric oxide. Which one is he? Well, there's one of him and one of him. He's O2 negative. Okay? So he's 2 negative. There's one of each, so then if he's 2 negative, he must be 2 positive. And so therefore, he's got to be iron 2 oxide or ferrous oxide. Now, inevitably, this is what students will do. Is they'll go with, say, let's go lead, PbBr2, okay? And so there's 2 of these guys, so it's lead 2 bromide or lead 4 bromide or plumbus or plumbic bromide. Okay, so you look this up and you say, oh, that's Br negative. There's 2 of them, so this side's got to be 2 negative. And if this side's 2 negative, then this has got to be 2 positive. Okay? And so then therefore, people would be, okay, great. That makes it lead 2 bromide. That makes it plumbus bromide. But inevitably what students will start to think is oh, it's just a reverse charge switch. This 2 came from up here, and so therefore, that must mean he's lead 2, right? Like, I just got to go back, and that'll be lead 2 bromide. I don't have to do all this other extra thinking. Well, that'll work most of the time, but there's a few exceptions to that rule. So let's do this guy, SnO2, okay? This is tin 2 oxide or tin 4 oxide, okay? Or it could be stannic or stannous, okay? So the tin could be 2 or 4. And what students will do is, well, that 2 came from the tin, so it must have come from up there, and so then he's tin 2 oxide. It worked for me before, and yeah, it may have worked for you before, but guess what? It didn't work this time, because that would be incorrect. Tin 2 oxide is not the correct answer. Oxygen is 2 negative. I've got 2 of them, so my negative charge in total has to be negative 4. My positives have to bounce off my negatives. So the positives have to be positive 4. And since I only have 1 tin, he's got to be positive 4, which makes him tin 4 oxide or, stannic oxide. Okay? So just be aware of that. That can happen. All right. Now, in this charge sheet here, let's go to mercury. Mercury here is 1 and 2. Like if you look at, say, gold 1 and 3, the charge is 1 positive, 3 positive, iron 2 and 3, Fe2 plus, Fe3 plus. Mercury 1 and 2, it doesn't mean that that's 1 positive or that's 2 positive. If you notice, the difference between the 2 is this little 2 right here, okay? That 2 has to stay. So what happens is when we're dealing with mercury, if we have mercury 1 oxide, mercury 1 is Hg2 2 plus, whoop. Oh. Oxide is O2 negative. Okay? We put them together, that 2 has to go there. Okay? And then because they already cancel out, that's the answer. I only need one of each, right? This would be a 2, this would be a 2. They're going to cancel out. And so we don't actually have to put them in there. Okay? Now, if it was this, mercury 1 chloride, then you write down mercury 1, and there's chloride. You put them together and do the charge switch. That 2 comes over here. It's going to be Hg2Cl2. And some of you are going to say, oh, I need to cancel those off, so it's just HgCl. No, that 2 has to stay there. And so therefore, that is your correct answer. That's right there. You don't cancel those off. Okay? If it's mercury 2 chloride, well, the only difference then is, if I can get this in there, I don't think I can. Okay, the only difference will be that instead of it being Hg2, it's just going to be Hg2 plus. And then we do the charge switch, and it's going to look like that, HgCl2. That's kind of like what we've normally seen. Okay, so that's how you do the common name system and the stock system. I'm hoping that's enough for you. If that's not, you still have the notes and a ton of examples in there. If you haven't got from that, take a look at that. But yeah, at this point, just pause, and if you have more Mrs. Pfister to come back to, if they get done, then push play again later, and I'll show you how to do the next part again. So pause. Okay, so let's pretend that you got, and maybe you did, you got copper, or the common name and the stock system all done. So you've done all this stuff here. Now we know how to do that. Okay, fantastic. What about this side? What do we do over here? Well, this is on the back side of your chart sheet, and basically all this is, these are called polyatomic ions, meaning that they've got more than one element in them. Like dihydrogen phosphate here, it's got H and P and O, and it's got 3 in it. Perchlorate's got Cl and O in it. It's got 2. Some of them, I think there's one here that's got more. Oh, maybe not. No, they all have 3 elements in them at the most, at least on here. So those are called polyatomic ions. How do we use them? Well, if you're able to do the stuff that we've done so far, I don't think you're going to find this very tough. You're just going to have to use some brackets. So remember mercury 1 that we talked about before? Let's talk about him again quick. Mercury 1, let's go nitride. So mercury 1 would be Hg2, 2 plus. Nitride is N3 negative. Slap them together, and then that 2 has to go there, right? We switch the numbers. The 3 goes here, and the 2 goes over here. But that's not right. It says Hg23. I don't have 23 Hgs. I have 3 Hg2s. And if you put brackets around that, you solve the problem. And that's the toughest thing that you're going to have on those polyatomics. Okay? So let's quickly take a look at polyatomics. I think you'll find these fairly easy. Okay, so let's go with iron 2 nitrate. Okay? Look it up, Fe2 plus. Look up nitrate, not nitrite, because there is a nitrate and a nitrite. If we take a look here, somewhere, there it is, nitrate, nitrite. This is NO3 negative, that's NO2 negative. They're completely different. Don't think they're the same, because they're not. So nitrate, is NO3 negative. Put them together. Okay, that 3 is part of the nitrate. It is not the charge. It's not NO3 negative. It's NO3 negative. Okay, switch the numbers. This 2 goes over here. put brackets around it to show that we have two NO3s. Okay? And that's about it. I'll do one more, and then we'll name a couple, and then you're good, I think. So let's go with aluminum. Oops, what am I? Yeah, aluminum carbonate. If you look them up, they'd be that. Okay? Put them together without the charges. The 2 comes over here. The 3 comes over there. So this would be Al2, CO3 in brackets with a 3. Okay? And that's how you do polyatomics. Now, we do not put the brackets there to show that we don't have 33 carbonates. We have 3 carbonates, but it doesn't mean that we're putting the brackets there to show that we don't have 33 oxygens, I should say. I'll show you where you get in trouble by doing this. Let's say calcium hydroxide. This happens all the time. Calcium is Ca2 plus, hydroxide is OH negative. People will put them together. The 2 goes over here, and they'll say, good, I'm done. Well, you'd be wrong. The reason being is because the way you have this formula written, you have 2 H's. You don't have 2 H's, you have 2 OH's. It's not calcium hydride, it's calcium hydroxide. And so therefore you need 2 hydroxides. Okay? Well, some of you are saying, well, there's no number there. It wasn't OH2, and then put a 2 there. That's not why you put the brackets. I have 2 OH's. Hydroxide is one like that, and cyanide's another one. Let's do cyanide. Oops. So we put them together. 3 goes over here. The 1 goes over there. We don't write ones. And so some of you would say, done. But that's not the case. You don't have 3 nitrogens. You have 3 cyanides. You have to put that in brackets to show that you have 3 cyanides. If you don't, it makes it look like you just got 3 N's, and that's incorrect. If we're naming, it's nothing really new than what we've done so far. So let's go with sodium phosphate. That would be that. You look up Na. Na is sodium. You look up PO4, that's phosphate. That's it, you're done. Okay? That's all you gotta do. That really hasn't changed. You still have to worry about those common name system and stock system guys. So you could still have, say, lead. So let's go Pb, CO3. Okay? It could be lead 2, or it could be lead 4, carbonate. It's still the same as before. Carbonate is 2 negative. That means the positives have to be 2 positive. They have to cancel out. Okay? And if this has to be lead, or has to be 2 positive, that must mean it's lead 2 carbonate. That part hasn't gone away. But doing these polyatomics doesn't make it any more difficult, I think. You just have to look on the back side of the sheet. I think that's it for polyatomics. So at this point, yeah, you have to do all that. So you enjoy that, and if you get that done, I've got another video for you that will be in another location. So don't miss me too much. Sarah, put your mask up and cover your nose. Connor, eyes up here, paying attention. And Faith, somebody will explain it to you. Okay, so anyways, you guys enjoy. Hopefully I'm here tomorrow. Bye now.